Avi, well, first, thank you for being on the show. I think it's perfect timing, and I'm so excited to talk to you about this.
Thanks for having me. It's a great pleasure.
I want to talk to you about Oumuamua. How do you pronounce that, first of all?
Oumuamua.
Oumuamua. Okay. So, regarding Oumuamua, for those who are unfamiliar, you said that you argued that it was most plausibly of extraterrestrial manufacture. And for somebody with your knowledge base and your background to say that most plausibly we found this thing that is of extraterrestrial manufacture is pretty astounding. Can you tell us a little bit about that and why you believe it is extraterrestrial?
Well, this was the first object that was identified as coming from outside the solar system based on its speed. It was passing near Earth and was flagged as a near-Earth object by a telescope in Hawaii that was searching for near-Earth objects to warn us against any threats from space. They realized that this object is actually not bound to the sun. It's moving faster than the escape speed from the solar system. And they named it Oumuamua, which means a scout in the Hawaiian language, because it was the first object identified as such, the size of a football field. And of course, the initial assumption would be to say, well, it's a rock, just like the ones we've seen in the solar system, coming from another star. But it was very unusual in its properties, and as more data came in, the more unusual it became. So at first, the amount of light reflected from it, it was roughly the size of a football field and was reflecting sunlight. The amount of light was varying by a factor of 10 as the object was tumbling every 8 hours, and that implied a very extreme shape, most likely flat, of a disk. That is unusual. You don't see that in rocks that we are used to. They usually change by at most a factor of 3 in brightness when they tumble. There was no cometary tail. There was no evaporation of this object that was visible. It didn't look like a comet, and yet it exhibited an excess push away from the sun. There was no rocket effect to push it, and the question arose as to what is this non-gravitational acceleration acting on it against the gravity that pulls it towards the sun. And the only thing that came to my mind was sunlight is actually reflected off it and pushing it. And for that, the object had to be very thin, like a sail. And nature doesn't make such things, so I suggested it may be artificial in origin. And then 3 years later, there was another object that exhibited exactly the same qualities. It was named 2020 SO, discovered in September 2020, by the same telescope in Hawaii. And after 3 weeks, the astronomers realized, oh, that one is showing indeed a push away from the sun as a result of reflection of sunlight with no cometary tail. They realized it's actually a rocket booster that was launched by NASA in 1966. And it had thin walls, and it was made of stainless steel. That's why it didn't evaporate. And so we know that this second one is definitely artificial because we made it. The question is, who made the Oumuamua? And there were other peculiar properties about it. My colleagues were saying, no, it should be natural. But then every explanation that was proposed involved an object of a type that we've never seen before. Not of the type of the asteroids that we're familiar with, not of the type of the comets that we're familiar with. And I say that you can't tell that it's natural if it's something that we've never seen before until you see another one. So for now, I argue that the artificial origin should be left on the table. And actually, the more interesting development since then was that I discovered together with my student, undergraduate student Amir Siraj, that there was an object detected before Oumuamua by almost 4 years, in January 8th, 2014. And that was a meteor, an object that collided with Earth at a very high speed. It was detected by US government satellites and was unusual in its speed, indicating that it came from outside the solar system, just like Oumuamua. It was much smaller, about half a meter in size, but it maintained its integrity down to the lower atmosphere of the Earth. And from that, we inferred that it had material strength, much tougher than all space rocks that were known, that were cataloged by NASA over the past decade, 272 of them. So that was actually the first interstellar object, not Oumuamua, because this one was cataloged, but both of them appear to be unusual. And the second one, this, the one that arrived first actually, the interstellar meteor, could have been a Voyager-like spacecraft. That would explain why it had very high material strength, maintained its integrity down to the lower atmosphere, and also why it was moving so fast. It was moving faster than 95% of all the stars in the vicinity of the Sun, relative to the local frame of the Milky Way galaxy. So it was moving at 60 kilometers per second, roughly the distance that a car makes in 1 hour. This object was making in 1 second. Just think about how fast it is. And the question is, why was it so fast relative to compared to stars? And one possibility is that it benefited from propulsion. So here you have it, two interstellar objects. Both of them appear to be anomalous. And I say maybe it's a wake-up call for us to recognize that there might be a lot of technological trash in space. I call it space trash, that kept accumulating over billions of years, just like plastics in the ocean. And we can just find it in our backyard.
Yeah. Well, and here's the thing, right? A lot of people listening, the vast majority of people on Earth right now do not have the knowledge that you have. So to you, I feel like the science becomes a little more clear, right? The mathematics, these things. But I think this is why people write it off. I think this is why people aren't as amazed, because it's easy for us uneducated to say, well, Avi mentioned that we don't know what it is. But isn't it more plausible that because the, space is so large, it's not that it's extraterrestrial, it's just, space rock that we haven't encountered yet because there's so much of it.
Well, but the thing is, if you look at the numbers, that in fact, for every star, you need 10 to the power 22 such objects to be ejected, like the meteor, for example, or in terms of Oumuamua-like objects, you need 10 to the power 15 of those to exist right now within the solar system. We saw that just the one that came close to us, but you just do the math of the statistics, random statistics of objects, and you find there is a huge number of these things. And it's really challenging to explain it because, I wrote the first paper a decade before Oumuamua was discovered, forecasting how many rocks we should expect from other stars, just based on what we know about the solar system. And we calculated that this telescope in Hawaii should see nothing because there aren't enough of them. Then Oumuamua was a surprise. It shows that my calculation was wrong. I was intrigued because there is an opportunity to learn something new. But the challenge is still there. How do you make so many rocks per star? Much more than you expect from knowing the solar system. And if you want a natural explanation, it needs to be very common. This process that makes them, this factory that makes these objects, needs to make many more than we expect based on what we know about the solar system, by at least a factor of 100. This discrepancy remains, even if you make it natural. Moreover, it didn't show a cometary tail, and you need to explain why it was pushed away from the sun. So people talk about a nitrogen iceberg, a hydrogen iceberg, or a dust bunny, a collection of dust particles. All of these suggestions have difficulties explaining the detailed properties of Oumuamua. With respect to the meteor, we've never seen anything like it. So the experts, quote unquote, these are playing the adults in the room, so to speak. I'm the kid saying, look, there is something strange here. And they say, no. Actually, we can explain it. It's just that the data is wrong. So they say the data by the US Space Command, which monitors for ballistic missiles, was measuring the speed incorrectly, and it's a factor of 3 smaller speed, and then it's a stone that is actually bound to the sun. That appeared in a scientific paper published in the Astrophysical Journal just last month. And for them to say that the U.S. government doesn't know what they're talking about when they deal with, the satellite data that they obtain, and actually the U.S. Space Command wrote a letter to NASA last year confirming at the 99.999% confidence that indeed this object, this meteor, is interstellar in origin. So they, took some time out of their day job, which is national security, to help blue sky research. And basically the Department of Defense came to my defense, wrote a formal letter to NASA. And now, a year later, these astronomers say, oh, we don't believe the US government. They made a mistake by a factor of 3. And my point is, if you believe that as an astronomer, that they made a mistake by a factor of 3, they didn't measure the speed correctly, how can you sleep well at night? Because they are getting more money than NASA to look for ballistic missiles and advise the US president. If they measure the speed of a ballistic missile incorrectly by a factor of 3, they might warn Mexico for something heading their way when it's heading to Washington, D.C. It's as if they don't know what they're talking about. And the other thing is, I went there. Okay, so I organized an expedition for $1.5 million with 28 exceptional professionals that came with me, the best in the world for ocean expeditions. We went to the site of the meteor that the US government pointed to, and we searched for any molten droplets from the surface of the meteor when it exploded, after it was exposed to the immense heat from the fireball that it created as a result of the friction with air. And we were looking for droplets the size of a millimeter, the head of a pin, across a region that is 7 miles in size, 10 kilometers. That was the region. And the depth of the ocean was roughly a mile over there. And just think about it, looking for tiny droplets the size of a grain of sand at a depth of a mile across a region of 7 miles. That sounds like a hopeless mission.
Sure does.
But the amazing thing is we found it. We found by now more than 700 such droplets. Moreover, we analyzed the composition of those here at Harvard University. I cannot speak about the details. They will come out after your broadcast airs a few days later.
Sure.
In a scientific paper that will be shared with everyone. And we are basically addressing the question, can we tell from the composition, just the elements that make up the droplets that came from this meteor? They were concentrated along the path of the meteor. There were more spherules, more of these droplets near the meteor path than far away. We checked that. We looked at control regions. Anyway, the excess spherules from the meteor, the question is, do they have a composition that is different from solar system materials? Because the entire solar system was made out of a cloud of gas that was enriched with the same abundances of different elements. And when we look at material that came from a completely different region in the Milky Way galaxy, it had very different abundances because those abundances come from an exploding star in the vicinity of the region where it's come. So we can tell the fingerprints of foreign material that doesn't belong to the solar system. And we have results that would address the question independent of the velocity measurement by the US Space Command. Forget about that. Just the composition itself is a fingerprint. And then beyond that, the next question is, given the composition, could it be technological in origin? Because if you imagine a Voyager melting off in a fireball by colliding with an Earth-like planet, like let's say 1 billion years from now, it exits the solar system and then it's not operating anymore, but then it collides with another planet like the Earth and burns up like a meteor. In that case, if there is a curious scientist on that planet that will go there to the ocean and collect the spherules, they might find that indeed it's not a rock. It would have a higher material strength, obviously, and will have a composition, let's say, of stainless steel, which is very different than a rock. Just imagine melting computer screens or semiconductors. They would have different composition of rare elements. So that's what we are addressing in this paper that will come soon, come out. And my point is, seeking the evidence. First of all, it was a risky project to take because it's very challenging to find those things. But without searching, you obviously will never find anything. And if you have a prejudice, you might not want to search because you want your prejudice to be valid. And obviously, that's what the people who believe that everything in the sky is stones, they wanted the government data not to be wrong, and they wanted me not to go there because there is no chance of finding anything. So I didn't listen to them. I'm not subscribed to social media. I don't care how many likes I have.
Sure.
I just went there. Then getting the team to collect the spheros by itself was an extremely risky thing, right?
Yeah.
I mean, getting it funded at $1.5 million, it's not a trivial thing. I didn't fundraise, and someone came to me, Charles Hoskinson, and provided the funds. So, and then bringing the material back and finding more than 700 spheros was not an easy task.
Sure.
And then analyzing them with the best instruments in the world. That's something I didn't know what the outcome would be, whether it will be possible. So there were lots of potential failure points along the way. But we can all celebrate the fact that we got to the point where we have results and data, and I can share them with the world. And to me, it's a triumph of also, sticking to a risky approach to doing science rather than insisting that everything we know already must be right.
Right.
To me, that's the whole meaning of my life, to learn something new. You can't learn something new if you insist that we know already everything, which is pretty much what the experts are doing.
I would agree with you. I've said this on the podcast. The experts, we've interviewed over 400 in different fields, and the ones who say things with entire certainty are the ones that I tend to trust the least, because it's just something I've learned. The people who really are at the top of their game, they always caveat things. They'll say, to the best of our knowledge, with our current data, the research shows.
It's a sense of modesty, by the way. It reflects modesty, humility. You have to acknowledge that your knowledge is incomplete. You make mistakes. Science is about making mistakes.
Right.
And when I was young, the most frustrating experience I had was at the dinner table, when I would ask a difficult question and the adults in the room would pretend that they know the answer, or they would dismiss the question if they have no idea. And to me, that was very frustrating, people pretending. And of course, the problem is when people become adults from being children, because then they learn how to fake it. They pretend as if they know something.
Yeah. Now, Avi, I got to ask you, because, again, you have to be aware that translating what you know into what we can understand, there's a chasm there that's really large. And so let me just kind of go back over some things in your book and some things we've talked about, and you can correct me where I'm wrong. A large part of what you talk about is it's unlikely that we meet extraterrestrial beings before we are aware of them through their technologies. And things like these technologies are what you're talking about. The quote unquote rock or whatever it is that you went and found, the Oumuamua, these things. What I don't yet understand is it truly that hard for us to differentiate between a rock and a piece of technology, even if that thing is extraterrestrial?
It's not at all, if you have good enough data. Yeah. So, for example, from the composition, you could tell the difference. By seeing a big piece, you can easily tell the difference. If it has screws and bolts on it, it has a label made on some exoplanet, it has buttons on it. In the last class of my freshman seminar at Harvard, in the spring semester, I asked the students, suppose we go out to the Pacific Ocean and we find a technological gadget with buttons on it. Should we press a button? And half of them said, no way, we are worried about the consequences. Please don't do that. And the other half said, of course, we would like to know what will happen. And then one of the students said, and what will you do, Professor Loeb? And I said, I will bring it to a laboratory and examine it before engaging with it. So don't worry. But obviously, the answer to your question is yes, if you have enough information about the object. The problem is very often we just don't have enough information, but people dismiss the opportunity to seek that information. They basically say, oh, I know the answer. The difference between a kid and an adult is that when there is an object lying on the floor, the kid would run to the object and start playing with it and learn what it is. Whereas the adult would look at it from a distance and say, I don't have time or patience or energy to go and check the object. I pretty much know what it is. And that is the wrong attitude when you deal with objects that you've never seen before. So the way to think of it is, suppose you live in an isolated family and you go out to your backyard and you find a tennis ball that was thrown by a neighbor. And then you realize we are not alone. Okay, so of course, if the US government found that information, the question arises, should we tell the public? It's just equivalent to asking, should I go back to my family and tell them that I found evidence for a neighbor? My answer is obviously yes, because your family might want to close off the windows to protect privacy. They might want to go out and chat with the neighbor. And even if you try to hide it, the neighbor might knock on your front door one day or affect your life in some way. And so in order for you to adapt to the reality that you live in, you really need to disclose that information. Now, it's also possible that if you find a tennis ball or if you find a package in your mailbox, the sender is already dead. The sender is not alive. That's quite possible as well. It just offers you an opportunity to get a better perspective about your neighbor. And it's much better than waiting for a phone call, which is pretty much what we have done in looking for signals from extraterrestrial civilizations. You can wait at home for a phone call forever. If nobody tries to call you, nobody is active at the time that you're listening, you would not get a phone call. But the advantage of looking for packages or tennis balls in your backyard is that they keep accumulating over time, and you don't need the sender to be active when you're looking for them.
Yeah, that's a good point. Let me ask you kind of straightforward. What percentage chance do you believe we have that tennis ball? We have proof of that tennis ball right now. And what is the best thing we have that is that tennis ball, in your opinion? What is that?
The material we collected from the Pacific Ocean is the closest I got to holding in my hands. And actually, if we demonstrate that it came from outside the solar system, as our paper will discuss, it will be the first time that humans put their hands, and here I am putting my hands, on the materials from a big object, bigger than 0.5 meter, that came from outside the solar system. Never before.
Really?
We had meteorites. These are rocks that came from the solar system, the building blocks of planets that were left behind, like Lego pieces.
Okay.
But we've never identified an object from outside the solar system. And in this case, the object in the Pacific Ocean was identified by the US government back in 2014 based on its speed. The fact that the fireball was moving very fast, cannot be bound to the sun, and we calculated it was moving very fast even outside the solar system. So that was the first time in history such an object was identified. But then we went an extra step, and you can think of the ocean as a museum, because at a depth of a mile, it preserves whatever lies on the floor, even though a decade passed, almost a decade since 2014. It was preserved, and we were able to use magnets on a sled to collect those tiny spherules.
Wow.
That you can think of it just as dust particles that represent the molten droplets from the surface of the object when it was exposed to the fireball. And finding them is amazing, and an amazing feeling. And if you ask me, whether it's technological or not, that is a more difficult question to answer, because you need to ask, okay, well, can I think of a natural process that would account for all the properties of this meteor, which we call IM1, interstellar meteor 1. Of course, one way to easily answer this question is to find a big piece, not these spherules tiny that are 1 millimeter in size, but actually a piece of the object, which we might do in the next expedition. So that would be the challenge that we will do next, to go there and see if there is any big piece that we can identify. And if we can, then of course it's very easy to tell a technological object from a rock.
Okay. That's what I was wondering, because you were referring to the fact that it was, outside the solar system. But in my mind, and again, no idea if I'm right, but it's like, well, is that a big deal if it's just a rock?
Okay, it's a big deal because even if it's just a rock that came from interstellar space. Because and by the way, first of all, to demonstrate that, we have to show the composition is different from solar system composition. So we will have some information about where it came from. And it means that where it came from looks distinct relative to the solar system, and so that already teaches you something. Oh, there are these environments that are very different. It's just like getting an object from the street. It would have a different nature than the objects in your backyard, and it already teaches you, even if it's natural, of what lies out there. But of course, if it's technological on top of that, that would be amazing, because that would mean that we are not alone, that there are intelligent beings out there.
Okay, that now I'm starting to get it, and you're right. It'd be like if you grew up on the East Coast where I am, and you went to the beach, and you thought that every ocean was the same, and then somebody gave you ocean water that was different. You'd be like, wait, there must be different oceans out there that I'm unaware of. Even if it's naturally occurring, it's not an extraterrestrial. Exactly. It's still proving that there's different solar system. Yeah.
Exactly.
Wow, that is fascinating. Okay, I got to ask you that. I mean, I could talk to you for days, but we don't have days. So I have to ask you this, because it is one of the things that's on people's minds right now. And I think it's a good time to be you, because if there has ever been a time where people are talking about aliens, it's now. And a lot of that is due to, in 2022, the U.S. government admitted to the existence of unidentified aerial phenomena. Could you tell us the synopsis of that for those of us who just can't understand it or can't deal with it? What did they say, and what is its significance?
Right. It actually started in June 2021 when the Director of National Intelligence, Avril Haines, delivered a report to the U.S. Congress and saying that there is a class of unidentified objects that military personnel and intelligence personnel report about, and they don't know what they are. And of course, it could be a mixed bag of things that the data is not good enough, but in fact, there are balloons, drones, we just can't tell. And 6 months later, I actually met Avril at the Washington National Cathedral. There was an event with Jeff Bezos and Bill Nelson, the head of NASA. And in the green room, before we went on stage, I asked Avril, you delivered this report, what do you make of it? She has a bachelor's degree in physics from the University of Chicago. So we speak the same language. And she told me, I don't know. So I believe her. I think the government simply cannot figure it out. And a year later, she delivered the second report, which said the same. And around that time, a new office was established in the Pentagon called the All Domain Anomaly Resolution Office, attempting to hear all of these reports, collect all the data that is available, including classified data, and check whether any of these objects appears non-terrestrial, that came from somewhere else. Actually, they are mostly interested in terrestrial origins because they want to figure out if there are any adversaries like China or Russia that are spying on the US. There was this incident with the Chinese balloon that was shot down. Right. That's an example. What the latest from the director of that office, who visited my home at some point, is that a few percent of these reports are not understood even after they look into them, whereas most of them can be explained. Okay, so as I said before, it's mostly a mixed bag, and it's mostly things that we know about, like balloons, drones, but there are still a significant number of objects, maybe a few tens of them every year, from that are recognized by military personnel that cannot be figured out given all the data we have. And the data is sometimes quite extensive, especially when it's classified. I haven't seen any of that, but at any event, so 2 years ago, after the first report from Avril Haines, I decided to establish the Galileo project in collaboration with Frank Laukian, one of the donors. And
could you tell us about that, by the way, the Galileo project? Yeah.
Yeah, so I can tell you where we are right now. The goal was, all of these reports by military personnel are anecdotal. Someone was at the right place at the right time and saw something. And it's usually not with calibrated instruments or instruments we have full control over. These are cameras that are in jittery cockpits, and you can't really trust the results. And so we decided to have a systematic study of the sky, meaning that we monitor the sky 24/7 all the time, and at multiple wavelengths, different cameras in the infrared, the optical, the radio, and audio. And we collect all the data and then analyze it with machine learning software. And the advantage of that is it's not only that you're looking for anomalous things, but you're able to calibrate the noise. You know what type of objects come back again and again that are conventional, natural. And then you know how unusual is something if it shows up. So in difference from the anecdotal reports, we get a better understanding of the noise, and then we can really claim if something is anomalous and get much better data on it and learn it. And so that's the goal of the Galileo project. We have one observatory that is already operating, collecting data at Harvard University, and then we are making a second a copy of it in Colorado right now, and more copies to come. And the goal is to have maybe tens or maybe 100 of these observatories spread across the United States, so we can get a census of any anomalous phenomena, and get to the bottom of it. And if it turns out that all of them are balloons and drones, human-made, so be it. Let's figure it out and move on. But my goal is to help the government figure it out, and they're interested in it from a national security perspective, of course. They want to know what most of the objects are. And I don't care about most of the objects. I just care about the question of whether there is anything at all, even a tiny minority, 1 in 1,000 objects that may be extraterrestrial.
Yeah, what surprised me about that in your book and as we talk is I would imagine most people have the same assumption as I do, which is if there were extraterrestrial objects within our data field, like not just within our atmosphere, but within something we can measure, we would know. Like,
no, it's not true.
And it's not true. It's actually, we are almost actively not looking for it, which is crazy to me. Yeah.
So let me explain that. For example, astronomers have powerful telescopes for many decades, but they are looking at a narrow region of the sky usually, and they are focused, they train their telescopes on very distant sources. So if a bird flies overhead, they ignore it. The only organization that monitors the entire sky is the US government, or any government for that purpose, because they are worried about ballistic missiles, about threats, about espionage, and so they would be the first to notice something unusual. And the claim is, at least there was a hearing in the US House of Representatives just last month, where 2 pilots testified that they saw things that are quite anomalous. And David Grush, who had a high security clearance, argued that the US has programs for retrieval and reverse engineering of alien spacecraft. He hasn't seen the evidence himself, but he spoke with 40 people that he claims are engaged in these programs. And he promised to give Congress people access to the contact details of those 40 people. And so there is a path forward here. If they approach those people, we might learn more in the coming months. And I just don't know what to make of it. It may be a fabricated story. It was given under oath, but who knows? And if it's real, it means that the US government already has the exciting details that we might all want to know, but for some reason it's keeping it hidden. I don't think it's appropriate for the reason that I mentioned before. I think it should be shared with all humans, like any scientific fact about our cosmic neighborhood is, because anything that came from interstellar space, started the journey before humans existed, doesn't really care about how we split the land among nations. Right. It's not a matter of national security.
Right. And that was another thing you explained really well in your book, which is this idea of we have these preconceptions of what I'm just going to call them aliens. Aliens might want, might do, might be, and they're almost entirely incorrect. simply because you have to think of their motivations. Like you talk about, why would they be interested in our wars? Like that's not a thing that would serve them. And so it's a way of changing our perspective of, if we do come in contact, what do they even want and how do we approach it?
Yeah. So if you look at religions, there is a very popular view that God looks over your shoulders and therefore you should behave morally. The reason that view was advocated, obviously, by those religions is to get control over people, to tell people what to do. The reason people believe those ideas, I mean, you can tell people whatever you want, they wouldn't necessarily believe you. The reason people believed it is because we have that reality when we are kids. You know, we have our parents looking over our shoulders. So it fulfills a need. As a kid, you know that someone is looking over your shoulders and checking. Then you grow to become an adult, you become independent, that authority is not out there anymore. And so you're looking for someone else that would be looking over your shoulder, and God is a good opportunity for you to maintain that view that someone is looking over your shoulder. Since you had the same view as a kid, it sounds completely natural to assume that. And if you think about the aliens doing the same, because obviously an advanced technological civilization is a good approximation to God. It could create life in the laboratory. It may even create baby universes in the laboratory. So if we imagine an advanced technological civilization as God, I would say it's very unlikely that it cares much about us. Because, it's just like helicopter parenting. I don't expect the aliens to be our parents. They're not our parents, and they're not interested in helicopter parenting, basically making sure that we do the right thing. They don't care less about it. It's just like you drive a bicycle on the street. You wouldn't care about what the ants are doing. If the ants on the pavement are going to the wrong crack, you will not stop your bike and try to direct them with your finger to the right crack in the pavement. I mean, that is ridiculous. Or if they're in danger of killing themselves because you see a drop of water and they're heading that way and they will die in the drop of water because of the rain, you don't go and correct them to go away from that. I mean, that is a ridiculous. And of course, it's an idea that stems from self-importance. Okay, we enjoy being self-important. So we thought that we are the center of the universe. Why? Because it makes us important. And then we put Galileo in house arrest when he claimed that otherwise, because how dare you even doubt that we are so important? Of course, no, that ends up being the reality that we live in. We are not at the center of the universe. But we still maintain the view that if there is anything out there that is superhuman, like a high-level technological civilization, it would care about saving us. Why would it care about saving us? I don't see any reason. First, we have to demonstrate that we are intelligent enough for them to care about us in the first place, because as of now, we are wasting most of our resources on fighting each other in wars, on military budgets. That is not an intelligent thing to do, right? Just imagine if Russia and Ukraine collaborated on a space program instead of fighting each other over some territory. I mean, it's ridiculous. In the First World War, my grandfather fought in the battlefield between the Germans and the French. He was on the German side. And there were 700,000 people that died in that battle of Verdun. And just think about it. Hundreds of thousands of people die. And they barely moved a feet one way or the other over a period of a few years. And it was all, a matter of being a patriot of your country and caring about your nation. But if you think about it, it's very dumb. It's not intelligent.
Absolutely.
And if someone looks at it from a distance, that someone would say, what are these animals doing there? Killing each other over some tiny territory on a piece of rock that they were born on. Who really cares about it in the big scheme of things of the universe? And moreover, they keep looking down all the time. These ants down there on this rock, they don't look up and realize there is much more real estate in space.
Right.
So my point is, we haven't proven yet that we belong to the class of intelligent civilizations.
Yeah, actually, you do talk about that, and we don't have time to discuss it all, but I loved your description of, A, B, C, D civilizations. And essentially the evolution of intelligence, right? So like where we are, and I agree with you, is we're pretty much at the lowest rung, which is we don't even keep things even. We are destroying, our home habitat and those around us. So that's just a tease for those as we talk about the book, if that sounds like something you're interested in. But Avi, I have to tell you, one of the things that was most striking when I read your book, like really finally answered a question, is you proved for me that it is most likely that if we ever find extraterrestrial life, they will be vastly more evolved than we are. Now, a lot of people make that assumption, but without any rationale. Could you tell us why that would make a lot of logical sense?
Yeah, it's very simple. Our science and technology is only 1 century old. So quantum mechanics, the foundation of modern physics, because reality is quantum, that was discovered just a century ago, exactly a century ago. And now it's the foundation for all the gadgets, the electronic gadgets that allow the two of us to converse, computers, internet, all of that is based on quantum mechanics. And we just discovered it a century ago. And a century is really a very short time compared to the age of the Earth or the age of the solar system or the age of the universe. It's 1 part in 100 million of the age of the universe. So that means that a civilization that preceded us must have had much more time if they developed their technologies, thousands, millions, or even billions of years before us. And most of the stars formed billions of years before the sun. So we are relatively late bloomers. We're coming late to the party. It's very likely that we can learn from those that were around for a while. So, we just came late to the stage, the cosmic stage. We are not at the center of it. So it means that the cosmic play is not about us. And if we want to learn more about what it means, we might want to seek other actors that were around longer. They can tell us what the play is about.
Yeah. And it's that last part that got it for me, which was, look, it's very simple. The sun is younger than most stars. So most places where life could exist, and you talk about there's a lot of them, they're vastly, more mature. So if you just do the numbers, right? If you're the youngest person at your school, it's likely that those above you, everyone else is going to have had more time to evolve and be intelligent.
Exactly.
It is a simple answer, but I think these types of questions rarely have simple answers. And that's why I was like, all right, got one solved. It's very cool.
Really, the most important thing is people say it's an extraordinary claim to even consider another intelligent species. I say that it's arrogant to think that we are alone. It's arrogant of us because it basically says that we are unique and special, pinnacle of creation, nothing like us exists anywhere. I think it's an ordinary assumption to say if we exist, someone else exists, because there are tens of billions of stars like the sun in the Milky Way galaxy alone, and then there are hundreds of billions of galaxies like the Milky Way in the observable volume of the universe out to the cosmic horizon, and there are many more beyond the cosmic horizon. We know that conditions continue for at least 4,000 times the distance to the cosmic horizon. So the point is that the numbers tell you that it's very unlikely and it's arrogant to think that we are the only ones. And what that means is that we need to search. And, it's not inappropriate to say extraordinary claims require extraordinary evidence, because the people who say that are not seeking the evidence. It's a circular argument. And I say extraordinary evidence requires extraordinary funding. And that is the way that physics, science is done, because when we don't understand what most of the matter in the universe is, the dark matter, we invest billions of dollars in the Large Hadron Collider to perhaps discover the dark matter particle. We have done that, and we haven't found anything. Nobody says that's a mistake, because that's the only way to learn. You have to invest. Nobody said it's an extraordinary claim to say that the dark matter is a supersymmetric particle that the Large Hadron Collider will find. Nobody said that. We invested the billions of dollars. We haven't found it. In retrospect, it was an extraordinary claim because it's not true. However, in the case of others like us, we know that we exist. we know that we sent out probes to interstellar space. And so what is more natural than to say things like us may have existed in other places? Let's check for their probes that they sent billions of years ago. Why is that not in the mainstream of science? That to me is an aberration of academia, where people are engaged for decades in the study of supersymmetry that turned out to be wrong, in the study of extra dimensions that we don't know exist for decades, and that is celebrated by Brian Greene, Neil deGrasse Tyson, as if that is the frontier of physics. Well, it's not, because we don't have any evidence. We don't have even an experiment in mind that within our lifetime will show us the extra dimensions. We don't have that. And yet it's celebrated as if. But then when we see anomalous objects in space, that is considered fringe. And I think that is an aberration. It's completely psychological. And it, of course, stems in part from the tendency of people to say, oh, talking about new symmetries of nature, talking about dimensions when we know there are some dimensions, that's okay. Don't worry about it, because we know that thing exists. But talking about, gadgets from extraterrestrial technological civilization, well, that touches a nerve, because then it means that we may not be the smartest since the Big Bang.
And you know what's funny about that? Maybe I'm wrong, maybe I'm weird, but I feel like the average person would love that news. It's the experts who are the ones who don't want it.
Well, so here I am trying to change that.
Yeah.
And I should say that the public really is fascinated by this. And also artists, there is a playwright that wrote a play about, and it will be shown in a month, about my research. He wants it to go to Broadway. There is a songwriter who wrote a song. There is a sculptor who is making now a sculpture. There is a documentary filmmaker that went with me to the Pacific Ocean.
Wow.
And there were 50 of them that wanted to be there. I chose one. And altogether, it's inspiring to people. I get email messages about it all the time. The only place where I get pushback, ridicule, bullying is in academia.
That's
and you
crazy.
ask yourself, why would that be the case? Because academia is supposed to be about openness of mind, about blue sky research. And people are, attacking me personally, even though we're talking about substance here and we should just stick to substance. But it's just peculiar to see that. And, just to give you another example, when we don't know what the nature of dark matter is, and we infer that there is dark matter based on using Einstein's gravity, and so it's possible that our understanding of gravity is wrong. This is called modified gravity as an alternative to dark matter. And some decades ago, when we had a junior faculty in my department, and when that person saw a paper saying, well, maybe dark matter doesn't exist, it's modified gravity of this type, he got extremely upset and emotional about it and said, this is nonsense, I don't want to hear about it. And to me, that's a problem to be solved by therapists. It's not the way science should be, because science should be open-minded. You should be, until you figure out the dark matter, the nature of the dark matter, the possibility that it's modified gravity should be left on the table. And the same is true about objects like Oumuamua or the meteor that we talked about. People should not get sick by considering alternatives that, when people insist that everything in the sky is stones, like those astronomers that worked on rocks for decades, I call it the Stone Age of science.
It's a really good point. On a brighter note, you do say in your book, we have never been so close to scientifically valid proof that life on Earth and human civilization are not alone in the universe. Why do you think, what gives you that hope and that opinion that we've never been closer? It is that. It is what you're holding. So for those listening, it's what you're holding. It's what we talked about earlier. It's those things you found.
Yeah, that gives me hope, because we went to find it. And you will see the results in the scientific paper. But moreover, it demonstrates that obviously if you are not searching, you will not find anything. Okay? So when Enrico Fermi said, where is everybody, without searching, obviously, it's just like a single person standing at home and saying, I don't have a partner. Well, to find your partner, you have to do some work. Okay, you have to go to dating sites. You have to look through your window. You have to go to your backyard. You can't just say, where is everybody? That's what Fermi did, and I'm really surprised that people echo that question. You can't just say that. You have to seek partners. And space is vast, time is long. Why would the spaceship just land in Los Alamos at the time that Fermi is having lunch? That is ridiculous. And it's the same as those people who say, well, I would wait for the partner to reach me. And that doesn't work, okay?
Right.
And the same with Elon Musk, who is engaged in launching communication satellites and claims, I haven't seen any evidence for aliens. Obviously, you're not an astronomer, right? You're not seeking. So I went there to the Pacific. I'm trying to do the work, and when I do that, I get pushback, which is really strange. Why would any scientist be object to the idea of collecting evidence? That is contrary to the scientific method. You want to seek evidence. That should be the way. I think they object because they see the interest of the public, the fact that it garners a lot of public attention. And it's simply because the subject resonates with the public. And I think as scientists, we should satisfy the interests of the public because, we are using taxpayers' money. And if the public cares about whether we have a neighbor more than what is the nature of dark matter, we should at least invest equally in the two subjects. As of now, we invest zero in the search for technological gadgets in the vicinity of Earth, and we invest billions of dollars in the search for dark matter.
I want everybody to hear that, because that is the most shocking thing that I learned, which is we're not looking. Because everybody listening probably thinks, of course we're looking. I mean, it's one of the greatest questions is, are we alone? And to hear that the people we think care don't really, to an extent, is amazing.
Push back.
It's amazing.
Not only don't care, they are angry about me going to the Pacific, about me saying that the meteor might have been interstellar. They want to kill it by writing papers that saying the government data is wrong. So they don't just say, I am wrong. They say the U.S. Space Command doesn't know what they're measuring because we want to fit it with a stone that came from the solar system. That's basically the paper that appeared last month. That's it.
It's crazy.
Now,
it's crazy.
It's not only that they sit back and relax and say, okay, well, I don't want to collect data. I have other priorities. No, they attack and attempt to say we discovered an object from outside the solar system. They have a problem with discovering this thing.
That's so weird to me.
So that shows you the headwind that I have to face. And moreover, there is no federal money allocated. Of course, there is a study that NASA established, which should come up with a report very soon, perhaps by the time your program will air. And if it recommends that NASA invests in the study of unidentified anomalous phenomena, then we might have some federal money allocated for this task. But as I said, the search for dark matter for decades has billions of dollars, and nobody doubts it, even though we haven't found anything. So the track record is zero. The track record of SETI searching for radio signals is zero. Nobody says anything about that. To me, it illustrates the fact that maybe we are using the wrong method. Why not look for objects? And what you find is the SETI people opposed, saying bad things. In fact, they are engaged in writing blogs, organizing talks that will say Oumuamua was a rock. They just organized it last month, a talk that says that Oumuamua was a rock. And then they had a blog post saying that, yes, Oumuamua is a natural object. Why would they be so eager to resist the possibility that we might have encountered? It's because they are very proud of the method they've been using for 70 years, trying to look for radio signals. But they haven't found anything. So my point is just, if someone doesn't find the dark matter to be supersymmetric particles, I can guarantee to you that they will have no objection if another team would argue that it may be an axion, a different type of particle, and would look for it. They would have no problem. But for the SETI community, if you don't do radio signal detection, then, they have a problem with it.
I have a feeling that I know what you're going to say here, but I'm not a conspiracy theorist, and I don't typically fall into them. But do you think there's any chance that there's also part of those in power who don't want us to find life outside of us because I'm pretty sure it would then change the balance of power? I really think if we had inconclusive evidence that we weren't alone, people's priorities, the way nations interact, they would have to change because our entire realization of what it means to be here would change.
Right. But think about Marie Antoinette when the French Revolution started. Obviously, she wanted to maintain power as the queen, right? And she was very worried, and she would have liked to suppress the ideas of the French Revolution. But who cares? The French Revolution took place.
Sure.
Right? The guillotine chopped a lot of heads, and we moved on.
Yeah.
And the principles of the French Revolution were endorsed by the U.S. Constitution, by the way, many of them. So my point is, who cares about this resistance?
Oh, I don't care. I'm saying, do you think the people in power care? Like, do you think that's true?
But that was Marie Antoinette, right? And so eventually, what I'm doing as a scientist, I will, the sky is not classified, the oceans are not classified. Eventually, we will know. And when we know, heads will be chopped. In the sense that we will not adhere to past practices. And that's what happened with the French Revolution. So we just need to bring in the revolution, that's all. And, Copernicus did that. Obviously, people back then thought that it would be destabilizing to society. That was called the Copernican Revolution, that the Earth is not at the center of the universe. And we are heading perhaps to another Copernican revolution. This one would be more significant, that we are not the only sentient beings out there.
Man, it would be crazy. Avi, I know we have to let you go, and so you can be as brief as you would like, but there is a term that you laid out that I was unfamiliar with, and I think it's really cool, and it's called Day 2. Could you tell us about Day 2, what it is, what it means?
Well, what do you do after the first encounter when the news breaks that, at least to you, that indeed we are not alone? And I think it would have a huge impact on reorganizing society and the way, changing our priorities and our aspirations for space. And of course, there is no protocol, and I would advocate that we shouldn't establish a committee that would plan for Day 2, because we don't know what the encounter would entail. If you have a visitor to your backyard, the way you respond to the visitor should not be decided by a committee ahead of time. You first need to figure out who the visitor is, because for different visitors, you will behave differently. So my advice is, let's wait and see who is visiting us before we decide what to do about it.
I love it. Avi, this stuff is incredible. These conversations spark so much in my mind, again, on my side of the table, just positivity, hope, curiosity, which is what this podcast is all about. So I appreciate the work you're doing. I love the book. I'm recommending it. We'll link to it. It's called Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Avi, for those listening who are interested in this, what do you want them to do?
Well, just join me in this thrilling exploration. And if you are young enough, you can become a scientist, and do not bow down to, do not necessarily dance to the tunes of those committees that make decisions that do not make sense, but chart your own path. And I think there is a great advantage to taking the path that was not taken, because you might find the low-hanging fruit. Nobody went there. And this should be, I think, a guiding principle for life. If you want your life to be inspiring, exciting, just define the path for yourself. Don't listen to what others are telling you.
I love it. Where can we keep up to date on this new information? You mentioned the paper coming out, the press release. There's so much coming out, but we don't know where it is. Any advice?
Yeah. So I have updates on medium.com.
Okay.
Avi Loeb at medium.com. I will have an essay explaining the content of the paper, linking to it, so you will be able to see it there, hopefully around a few days after your podcast airs.
Fantastic. That's great. Avi, thank you so much for sharing this with us.
Thanks for having me.